My name is Edward Stevens, and this is my Physics 2 Lab 1 Charged Tapes lab. In this lab, we created electrically charged pieces of tape to see how the charged objects would interact. We did this by sticking the pieces of tapes together after making little tabs on them to help be able to pull them apart after we stuck them together. And then after pulling them apart, we would drift them closer to each other and then see if the charges would repel or attract to see if one tape or the other had gained some kind of charge. Now, this lab helps see how the charges interact, how opposite and like charges interact, how they attract and repel, and the transfer of electric charges between objects is when we handled the tape too much and they would lose their charge. Now, this lab is based on the following physics principles: electrical force calculations, where we calculate the electric force at on an object a certain distance away. The interactions of charged objects, as in like objects repel and opposites attract, and gravitational forces from Physics 1. In this lab, we made many observations. Because we saw the two U-tapes repel when close together, we concluded that they had the same charge. And because a negatively charged object attracted the tape, we knew that it must be a positively charged piece of tape. In our experiment, we had to float one piece of tape on top of the other using the electric forces generated by pulling the pieces of tapes apart. Here you can see my calculations and observed data. You can see that for the charge of the second piece of tape, the one that was floated, I got 2 times 10 to the negative 9 coulombs. Here you can see my programming slide and the code that I used to generate the two tapes floating experiment. The top piece of tape, the floating one, is red, and the bottom one is green. The orange arrows that extend upwards and downwards is the electric force exerted by the pieces of tape on each other. And the blue arrow is the downward force of gravity. In my simulation, I had to assume that the charge was equal along the entire piece of tape, and I had to simplify the experiment by only applying charges to each of the center particles, as the ones on the edges do not exert a force. Now, there could have been many sources of error in this experiment, as any other forces acting on the pieces of tape creating incorrect measurements, or air blowing on the pieces of tape, or handling the pieces of tape too much where they began to lose their charge. A few final questions. What if electrons had a positive charge and protons had a negative charge? And what would change about the observations you made with your tapes and other charged objects? Actually, if all the charges were reversed, then the interactions between all particles would remain the same. This is because the electrons would now be positive and they would just be attracted to the protons that would now have a negative charge, and nothing would change about the standard interactions between these particles. Last question. Why is it important to handle charged tapes as little as possible? Well, when the charged tape is handled and touched, the charges will leak out of it through conduction, meaning the electrons that have a charge within the piece of tape will transfer to some neutrally charged object, charging it a little bit, but really lessening the charge in the piece of tape, therefore making it tougher to float on another piece of tape. Thank you for listening to my presentation.